So the question, the first type would be to simplify. So an example, okay, so where people go wrong when they're simplifying a trig function is that this is sine of x, and this is sine of 2x, and they can't cancel each other out. The arguments can't cancel out. You can't do anything to simplify this at all unless the argument, that's whatever comes after the trig, is the same. And they are not the same. One's an x and one's a 2x. So you can't do anything as it is. But there's an identity for this. And what's the identity? Sine 2, I put theta up here, but that could be a 2x, is 2 sine x cos x. That's the identity. So instead of the sine 2x, we'll put this in. And now we can cancel because the sine x has the same argument. All right, so we can cancel out the signs, and what would we have left? Anything else cancel? 2 and the 4. The 2 and the 4, yeah. That would be left over 2. So what we have left is 2 over cos x. And that would be your answer. You could put a bracket around the argument or not. It doesn't matter. When I spoke to the other instructor teaching this course, he said that he always puts brackets around the argument. So I said, okay, well, I'll do that in class tomorrow so that they are used to both. Because on the final, he said, I told them that I always had to have a bracket around the argument. So I said, okay, well, I never put a bracket around the argument, so I'm going to try to do that tomorrow in class so they get used to that. Okay? Because I made up the exam. He said, can you put brackets around all the arguments? I told them they had to do that. So I went back and did that. So in other words, the brackets. And so on. Okay? So just so you know, that means the same thing. Just kind of holds it together. Okay. That would be it. We could write this one more way. What's 1 over cos equal to? It's up here. This one right here can be 1 over secant or 1 over cos. You can write 1 over cos is equal to secant. They're reciprocals of each other. When you flip over cos, you get secant. When you flip over secant, you get cos. So this is a 1 over cos. We could write this as 2 times 1 over cos, which is 2 secant. Okay, so.
Does it matter which form we leave it in?
No, on the test it says show that this is equal to.
Alright.
So then you'd know where to stop. So on the test I put that, like simplify or show that this big expression is equal to 2 secant. So you would know that, okay, I got this far, now I need to see how I can get secant. Okay, another example. So what do you think here? You've got the identities written down. What's 1 over secant? Or cosecant. Remember, it's the opposite letter. So, sine. What would be 1 over secant squared? If you square a fraction, what happens? You square the top, 1 squared is 1, and square the bottom, cosecant squared. And with trig, we usually put the squared between the trig function, the ratio, and that means the whole thing is squared. So saying sine squared of theta is saying the whole thing is squared. Okay, Okay, that means the same. And that's not equal to sine of theta squared. What's the difference here?
Check theta.
Right, this would be, the argument is squared, and the other instructor said, I wouldn't put that like that, I would do this. Right, which sort of makes sense, that looks better, it would be less confusing, but I don't usually do that. Okay, so back here, what would be 1 over cosecant squared? So 1 over cosecant is sine, so 1 over cosecant would be sine squared. And what about 1 over secant? Doing the same thing. Cos squared. And this is equal to sine squared plus cos squared is up here. Equal to 1. So this is equal to 1. Okay, so a little more complicated. Any thoughts? And it's okay if you have no thoughts, because I'm going to show you. So you can also factor. So look at the top. What could we factor out of the top? What do the two terms on top have in common? What do they both have? So a term is separated by a plus or minus.
Sine.
They both have a sign. How many signs? Just one, because that only has one. This has 3, but we could take 1 out. So if we took one sign out of sine cubed, we would be left with sine squared. And if we take that sign, divide that sign out, we're left with cos squared. Now look what happens. What do you see now? We already just did that identity. Sine squared plus cos squared is 1. We don't need to write the times 1. This is equal to 1. That's an identity. So we have sine theta over cos theta. That's also an identity. What's that equal to? Sine over cos? Tan. So this is tan theta. Now I'm not showing you what the final answer is going to be here, but and actually in calculus, in integral calculus, the second calculus, you don't know where the end's going to be, but basically what we need to do this for in calculus is that you have a complicated expression that you need to take the integral of, which is the backwards of the derivative if you've taken calculus. And this is way too complicated and you can't do it. But if it's simplified to something nice, then you can take the integral of tan, and that's just a memorized one on the list that you're going to memorize. So no work involved, right? So that's what you'll be doing. Do you have a goal in mind in calculus? No, because all you're trying to do is make it into something that you can take the integral of. So you have like a list of integrals and techniques that you can use. This isn't in one of them. So you have to say, okay, well, I must be able to simplify this so that it looks like something I can use. And in fact, there is a technique to integrate stuff with sines and coses in it, so you could have stopped here and done it. Or if you realized that it was tan, then you just do tan, and then that's memorized. So it's a one-step question after you've simplified it. Right, so that's what you'll be using this stuff for in calculus, is you have to take a complicated expression, simplify it in order to be able to apply the rules that you learned. Here, in this class, I'll give you what I want you to end up with. So I'll say, show that this is equal to tan. Right, so you know where to stop. In calculus, you don't know where to stop, but you're just trying to find something that will work. This is right out of the calculus. Square root 9 minus 9. Now, I did this so many times. This is equal to the square root of 16, which is 4. What can you not do here that people mess up by mistake? Split them up. And when are you allowed to split up a square root? When they're multiplied only, not when they're added or subtracted. And these are subtracted, you cannot split that up, so don't do that, that would be wrong. This is not root 25 minus root 9. That's wrong, that would be 5 minus 3, which is 2, not 4, which is the right answer. You can't split up a square root unless it has multiply. So, we can't do that. What we could do, though, because both terms have a 9, is we could factor out the 9. So this would be 9. If we take a 9, divide 9 by 9, 1. Divide 9 by this, we get sine squared. Now, we could split up the square root because there is a multiply in here. What do we have a multiply? What do we have multiplied? 9, and then we could do 1 minus sine squared separate. But we still can't separate this one because of this minus sign in it, but this would be 9 times that. So we could do that. What's the square root of 9? 3. Now, this is an identity. 1 minus sine squared is one of the identities rearranged. So let's look at the identities. Which one has a 1 and a sine squared in it? Right here? If I move the sine squared over to the side with the 1, don't I get 1 minus sine squared? Which is what we wanted. So this is actually an identity. Sine squared plus cos squared equals 1 can be rearranged to be cos squared equals 1 minus sine squared. Moving the sine over. So 1 minus sine squared is equal to cos squared. And what would the square root of cos squared be? Square root and a square cancel out, so this is your cos. That would be your answer. There's a whole section on example questions like this in calculus with the square root over, and they always simplify the same way. You use the identity, put it in, and then it works, and then there's no square root. That's a whole technique on how to integrate. And each question takes about a page to do. But that's an important part of it, is doing that. Okay, so what about this one? So you should notice something first. In the very first example, I said you can't do anything unless the arguments are all the same. So where's the problem in here right now? The sine 2 theta. It has the 2 with the argument. Put it in the brackets so you can see that. That's a 2 where the rest of them are all theta. And there is an identity for that. So what is that identity? Sine 2 theta is 2 sine theta cos theta. So we're going to put that in here. Now this doesn't look much better, it actually looks worse. And I didn't tell you what the answer is going to be, but it's not this. So, what would another idea be? What could we do? So one technique of simplifying trig expressions is converting everything to sine and cos, because no matter which trig function it is, can be converted to be sine and cos. So what's tan in terms of sine and cos? Right, sine theta over cos theta. And is there another thing in here that's not a sine or cos right now? It's secant. And it's secant squared. Secant is 1 over cos. So what would secant squared be? 1 over cos squared. Okay, so we talked about that already. So we're going to use tan and secant squared, and we'll put those in. So this would be sine theta over cos theta. Now get that written down, and I want you to take a step back and look at what you just wrote and see if it's actually the same thing as me. So look at my denominator, the bottom of the fraction. I've got 2 sine cos times, how did I put this fraction? Remember, every number is a fraction, so these are already over 1. We're going to multiply the tops and the bottoms, so you have this fraction lined up so that the 1 is beside the cos, and this is beside the bottom of that. What I mean is, you shouldn't have the end of this looking like cos theta times 1 over cos squared. That doesn't look right. Because it's not obvious that you multiply the cos by the 1, and the 1 that's on the bottom of this by the cos. That's not obvious. So look at how you line up your fractions. So when you multiply these, this is like one big fraction on the bottom. And what do we have? On top, we have sine over cos. And on the bottom, what's the big long fraction? 2 sine theta cos theta divided by cos squared theta. Because 1 times cos squared is just cos squared. Do you see that? Now what do we do when we divide by a fraction? We rewrite the top, and we multiply by the reciprocal, which is flipping over the bottom. So we flip over the bottom. And we divide by a fraction. Okay, so now this is still one big long fraction, because when we multiply fractions, you just multiply across. So we've got one very big long fraction, sine squared and cos squared, or sine and cos squared on top, cos times 2 times sine times cos on the bottom. So what cancels? So this and this, yeah, actually. How many coses are on the bottom? So cos squared, and we've got a cos squared on top. So what do we have left? 1/2. Yeah.
I did it differently but got the same answer.
Yeah, and that's totally fine.
Okay.
Yeah. earlier?
I replaced can with sign, trying to tweak it.
Oh, yeah, that's fine. Okay, so, yeah, and what, like I said on a test, it's gonna say, show that this is equal to 1/2.
Okay.
And however you do that, if you get 1/2 and it's legitimate, when I look through, then you'll get the marks for it, right? Yeah, some people, will put and it's smart to do this, but put a bunch of crap and then it has the right answer and you're hoping that I won't notice that you just kinda threw something together. That's what people that cheat usually do. They'll see the answer on someone else's and make sure that is that answer, but then they have a bunch of garbage in between. They don't get the marks for that. And I usually know this.
Is it okay with, if I put like the secant squared theta, I change it to the cosine, move it up
Yeah.
right away?
That's what I would have done, actually. I try to stay consistent in class with what I do. All right, so then there's the second type of question on identities. Actually, this isn't really much on identities, but let's say solve the trig equation. So, this is more trig values, but going backwards. So we'll just solve a few of these. So, thinking back to your table of values that you have memorized. Where does sine equal 1/√2? In other words, what is the reference angle? Now, I didn't bring the table, I could recreate it, but does anyone know? Pi over 4 is right. So, can you picture that on your table? You're just looking backwards. So we've got the pi over 4 at the top of our table. So sine, cos, tan, 0, pi over 2, pi, 2 pi over 2, 2 pi, pi over 6, pi over 4, pi over 3, 0, 1, 0, 1, 0, 1 over 2. And I'm not even putting tan in because I don't know if I need it yet. But there they are. So, but tan, what do we do to get tan? Divide. That took me maybe 5 seconds. Writing time, right? That's how well you need to know it. So I can actually picture it in my mind now without looking at it because I know how to write it. So here, we're just going backwards. So we're saying, where does sine equal 1/√2? Well, it's at pi over 4. Okay. Now, pi over 4 can actually be here as a reference angle, here, in any of these 4 spots. That is where you would see the reference angle pi over 4. It can be in any quadrant. When you draw your angle, you would then say, what's the reference angle? Okay, the leftover piece between that line we drew and the x-axis is pi over 4. These are where it could appear. Now, this particular question is saying, where does sine equal 1/√2 when we are between 0 and pi? So where is between 0 and pi on this graph? Where's 0? It's here. And pi is here, that's 1 pi. So this is where we're looking. We're not looking down here. They just want to know, where does sine equal 1/√2? Is it here or here? Which one? How do you know which one's the right answer? what's the difference between drawing a pi over 4 in the different quadrants? Why does the quadrant matter? What does that tell us about the value?
Positive or negative.
Positive or negative? What one is this? Positive. So we want the positive quadrant. So theta would be equal to, which one is the positive? Both. You see the sign is positive both here, all are positive, and sign is also positive here. So there's two answers to this. What are the two answers? So you go to the start, and how big is this? How far do we go to get to this first line? Pi over 4. Start, and how far do we get to that second line? Remember, this is a whole pi with one piece taken out of it. They're cut into 4, so how many? 3. 3 pi over 4. So from here, we would get to eat 3 pieces, because there'd be 1 left over. So that would be the answer for this one. What if I had said the same question, but I put a negative sign here?
Wrong too.
No. The same question with the same interval, but I put a negative here.
Start at the bottom.
No,
Just go down.
no, because between 0 and pi is these two quadrants only. Sign is positive both here and here, so there'd be no solution. Right? You can't have a negative in one of these two. So if I had said sine of, so let's just write that as a little note here. Sine theta equals negative 1 over root 2. In between 0 and pi, what? Has no solution. And you could add to that, just say, because those two quadrants are positive, there's no negative answers in those two quadrants. So I would have had to give you a different interval. If I gave you a different interval, then yeah, you could answer, because you could go down to the bottom. Okay, so let's do another. We've got our table there. All right, so this one. So what's our first question? We need to know what the reference angle is. So you say, where does sine theta equal, what would you look up on the table? 1/2. You don't need the negative, because the negative is just about the quadrant. It's not what answers are in the table. So where does sine equal 1/2? That would be theta equals pi over 6. Their sine is 1/2 up here, pi over 6. Now, which quadrants are we talking about this time?
Positive.
No? 0 to 2 pi. 0 to 2 pi. So all the way around all 4. Yeah, and your answer's right if you're thinking ahead of me. So, but which ones do we want? We want where sine is negative only, because the question will have a negative. So which ones are we looking in? We don't want the top two, because that's where sine is positive. We want the bottom two, so we're looking at the reference angle being in those two. So let's draw that reference angle in each of those quadrants and see what that's equal to. So we get pi over 6 here and here, because those are the two that are negative. Your start is still here, So our first angle, we go from here to that first line. So you say, how many pieces would that be? They're cut into 6. You have a whole pie, which would be 6 pieces to here. And then one more, so 7. 7 pi over 6. Now, back to the start, and go to the second line. How many pieces would this be? So all the way around back to the start would be 11 pieces, because they're cut in 6, we do 6 and 6. We want one less, so this would be 11. So theta is equal to 7 pi over 6, or 11 pi over 6. Now, do they always have 2 answers? If I give you the whole way around, yes. But if I only gave you part of it, then no, might only have one answer. Sometimes I could say, like, where does sine theta equal plus or minus, and put both, and then that would be all 4 answers instead, because you could have the plus ones or the minus ones. So let's do another. So here I'll say tan theta equals -1, and theta is between negative pi over 2 and pi. We'll make it really weird. Okay, so we'll look at what this means in a second, what quadrants we're talking about. Let's first look at tan. So if you look on the table, I didn't fill tan in, but we can do that pretty quickly. Where does tan equal 1? Don't worry about the negative sign. So back to my table. These are zeros and undefined. This is 1 over root 3. This is 1 over 1. And this is root 3 over 1. So 1 is right here at pi over 4. So that's our reference angle, pi over 4. So tan is 1 at pi over 4. Don't worry about the negative sign. That tells us what quadrant to look in. So our reference angle is pi over 4. And we got that by looking in the table. So which quadrants are these? So here's our start. Where is negative pi over 2? How do you get to negative pi over 2 from the start? Negative goes down, so it's here. So we want that quadrant. And then where do we want to go in the other direction? All the way, this is positive, all the way to pi. So what's this saying? We don't care about this one, but the other 3 are fair game. So we can do that, go backwards and forwards. If you wanted these 3 quadrants, you can't go forwards to get them because you have to go through here. And if you didn't want that one, that's why you go backwards. So, because it's always starting from the start. So forward is pi, backwards is pi. Okay, so which ones are negative for cos? Or for tan, sorry. We want negative. So is C negative for tan? Yeah, because the only thing positive is cos, so we want this one. A is positive for everything, so we don't want that. And F, yeah, F is negative for, or positive for sine, so it's negative for tan. So we want those 2. Our reference angle is pi over 4, so we want pi over 4 right here. Remember the reference angle is between a cut mark, or a terminal arm, and the axis. And we also want it down here. Here's our start. So we want to go backwards to get this one. What would that be? Negative pi over 4. wants to go forward to this one. 4 pieces with 1 removed, so 3 pi over 4. So theta equals 3 pi over 4 or negative pi over 4.
Would it always be like that instead?
Yeah. What you don't want to do, what would be wrong, and you'll see these exact questions in 1003, they do them over again. What would be wrong is to do this. So you know your reference angles are here or here because of the negative. This one is 3 pi over 4. And what sometimes people will do by accident is this. And say, well, it's 8 altogether, so that's 7 pi over 4. Yes, that's the same terminal arm, but why is that answer wrong? I went through a part that's undefined for this question. And you can't go through it on undefined part. We didn't want to go through this part. And that's not between these angles. That's between 0 and 2 pi. That would be the answers if I had said between 0 and 2 pi. Okay, so that was close to 2 pi. If it starts with a negative, you want to go backwards to get that one. Yeah.
If you have an undefined part on both sides and a defined part in the middle, can you not get this?
Right, they can't ask that.
Okay.
Okay, I'm wrong. They can ask that, but this is how they would list that. So what your question is what if we just wanted like these 2 quadrants, but we didn't want one attached to the start, so you couldn't get there?
Mm-hmm.
So what that would look like is this. Let's say, there. And I thought of another example I can show you too, but, so where is this? So pi over 2 is here, and 3 pi over 2 is here, and they want theta to be in between that. So which quadrants would we be talking about? C, A, F, or T? We want to go between pi over 2 and 3 pi over 2. So S and T. So those would be the 2 quadrants in this question. Yeah, so it doesn't have to be attached to the start, but it has to be attached to each other. You can't do it like S and C and not have these 2, unless you're listed as 2 different intervals, which you wouldn't.
If you have S and C undefined, but then A and C defined.
Right,
can you
so
not
how
get
would you
C?
do that? So we'll finish this question in a second, but, so if we wanted, say we wanted A and T only, I would have to say 0 to pi over 2, comma, pi to 3 pi over 2. You see it? So this one would be here, and pi to 3 pi over 2 would be here. Yeah, so you'd have to list them separate. You couldn't list them all together. Yeah. Okay, which I'm not doing, but it's totally legitimate. Like, this is something you'd be expected to figure out. If you were given this, you'd be able to figure out these limits. Okay, so this question's a little different. The hardest possible for now, then they go back to these, like I said, in 1003, and you'll have to factor expressions with trig in them, using quadratic equation, find the values, and look them up. So there's a lot more to it. How would we solve for cos here? So it's a squared, so we could do difference of squares if we move the half over, or we could take the square root of both sides. But if we take the square root of both sides, what do we need to do? They don't really like this because everyone forgets to put the plus and minus. square root of 1 over square root of 2. Square root of 1 is 1. Root 2 doesn't work. And here's an example with both plus and minus. So each quadrant works because they're either plus or minus. You don't even need to worry about where it is. But this question we said is either S or T. So both plus or minus, you don't need to worry about whether they're plus or minus in here, but in fact they're both minus. Oh, what's the reference angle? 1 over root 2. Pi over 4, that's from the table. So since we only wanted these two, pi over 4, pi over 4. It didn't ask for the other two. So here's your start. We want to go in the positive direction for both of them. So we'll go here, which would be what? Take away 1 pi over 4, so 3 pi over 4. And then the second one, 4 plus 1, 5 pi over 4. And we didn't have to worry about the plus or minus because they're both there, so either answer is fine. Both plus and minus.
Doesn't it start from pi over 2?
When you're labeling them as the start is always here, whether you go through that or not, we're talking about one in here. It's called 3 pi over 4, which lies in between these two. Yeah, so it's a good question because to label it, to say what it's called, is always based on the start. Okay, the names of them are always based on the start. Where you land is what's important. So we want to land in here, but we don't ever start from here and just call that pi over 4 just along with these. We always start from here to give them a name. So wherever you want to land, always starts from here. Okay, so that's it for that section. And again, I posted a whole bunch of review questions for you to try. If you didn't do the homework for the logs and trig yet, you should do that. The exam is not far off, but no class on Friday.